Imagine an entity from the distant cosmic void hurtling through the solar territory at an unbelievable speed. It violates every familiar physical principle we've ever learned, accelerating in a way no comet would dare attempt, then suddenly blazing brightly at a moment when it should be silent in the freezing darkness. The entire blue planet suddenly holds its breath in that instant. Astrophysicists frantically rummage through every outdated theory to find a reasonable explanation. Senators from various countries unanimously demand emergency reports from space agencies. A tense atmosphere envelops the globe like a heavy black cloud. Then NASA's acting head Shaw Duffy completely ignores all calls for transparency from the press and scientific community, choosing to quell the public frenzy with a tweet so short it's hard to believe. No grand press conference, no publicly released data tables, just a response to Kim Kardashian's worried status on social media. The content is simplistically naive: no aliens, no risk of extinction at all. The world chuckles as if watching a joke. But the research community can't laugh, because behind that casual tweet is a cosmic rock behaving beyond every natural law ever recorded. NASA's reaction quickly becomes a catchphrase on every scientific forum. At this point, humanity suddenly realizes something is seriously wrong. Either this agency is in chaos behind soundproof closed doors, or it's lightly concealing information before the truth explodes like an atomic bomb. Join me in flipping through each page of evidence about NASA's bizarre attitude tonight in the silent space. What is about to be revealed will leave no one mentally prepared to accept it calmly. If this secret still keeps you awake at midnight like me, don't just sit still in the dark corner of the room. Remember to like and follow the channel to catch every hot development in real time. Leave a comment saying which country you're watching from, what local time it is there, and whether you believe we've grasped the full truth about this world-upending phenomenon. If you want to spread the message, share the post on every social media platform you have. You are the motivation for us to continue digging into the darkness. Start part 1 with the core question. The core question that's keeping everyone up at night. Imagine at the end of October 2025, an extrasolar entity tearing through interplanetary space at a terrifying speed beyond all predictions. Scientists struggle to find explanations in the chaotic data pile. Anomalous phenomena pile up day by day, hour by hour. Then suddenly NASA's acting director chooses the strangest coping method in history. No press conference, no scientific presentation, and no detailed data tables publicly released to experts. Shaw Duffy only replies to Kim Kardashian's tweet in a way so short it's hard to believe. The content is simplistically naive. No aliens, no risk to Earth's life. That's it. That's the only official message for the strangest interstellar visitor humanity has ever recorded in astronomical observation history. A cursory denial on a celebrity's social media, while experts and senators beg for clarity from the space agency. We rightly name this phenomenon the moment NASA departs from every normal script in a baffling way. What makes your heart tighten is that this kind of message doesn't arise from nowhere. Either it's panic disguised under fake confidence, or a plan calculated down to the smallest detail. The entity named Atlas III is confirmed as the third officially recognized interstellar object. Atlas is the survey system that detected it on July 1, 2025. In theory, just an icy comet wandering from the dark universe. But it resembles a comet in not even one small feature. This cosmic rock spews evaporating nickel vapor even billions of miles from the sun in freezing space. It accelerates beyond every gravitational model ever built. Hyperbolic orbit completely retrograde to every object in the solar system. Latest images show a gigantic jet stream pointing straight at the sun like a rocket arrow. The upside-down story challenges all knowledge of how comets work in space. We've seen how eccentric comets can be through many examples. They appear farther than predicted, fragment into dust clouds, surprise us continuously. But this is a completely new level of strangeness with no precedent. Nickel vapor cannot appear at such a distance from the sun. Abnormally low water ratio compared to carbon dioxide, inverting every scientific prediction. Size estimates fluctuate from Manhattan size to over 11 kilometers according to different reports. Perihelion timing on October 30th, 2025, around 1 a.m. at 1.4 astronomical units from the sun. Yet the only public message is a tweet replying to a reality TV star. The question for anyone interested: why does NASA, built on rigorous science, choose to respond via entertainment figure's social media? Did the data or the entity itself force this bizarre communication strategy? NASA has clear protocols, a dedicated office, a space phenomenon management team. Yet faced with increasingly thick anomalous evidence, they choose the Kardashian tweet to reassure the public. We are not rushing to conclude what Atlas III really is at this moment. Science needs time for peer review, complex data analysis step by step. But we scrutinize NASA's handling of the issue because organizational behavior reveals priorities, concerns developments behind closed doors. Currently, that behavior signals profound instability, hard to believe. There are only two ways to view the situation, and both are hard to swallow easily. Possibility 1: system panic combined with unprecedented aggressive image management. NASA caught off guard by a phenomenon unprecedented in observation history. Anomalies piling up faster than old models can explain. Internal models severely deviate from real observations. Scientists hold emergency meetings discussing the meaning of every new finding. Instead of admitting uncertainty, they choose absolute confidence via the friendliest channel tweet. The star that everything's fine, go to sleep. Possibility 2 is far more concerning than ordinary panic. If not panic, then active information control from the highest level. NASA knows or suspects Atlas III is far more important than publicly stated. Possibly artificial science behavior beyond every natural model. Classified data changing humanity's view of the universe. Strategy becomes prevention, controlling the narrative before it complicates, ensuring the public hears no threat before any other information. Both scenarios have reasonable evidence based on available data. That's why the issue is this fascinating and worrying. We are not just facing a space mystery, but a mystery of the behavior of those researching it. Throughout the investigation, we will dissect every piece of the big picture. View the event timeline. Anomalies making Atlas III. Unusual data gaps, headache-inducing for researchers, institutional models explaining reality. Explore scientific details, understandably even if you haven't studied advanced physics. View NASA's communication history to see if this behavior follows a pattern or is a complete mutation. Careful, responsible speculation on the meaning of different outcomes for cosmic understanding. It all starts from the star's tweet and the agency prioritizing reassurance over truth revelation. The story will get much stranger in subsequent parts. Part 2. Latest development timeline from start to finish. Follow exactly how we got here in space and time. The chain of important events is not just discovery and a simple tweet. It's observations, decisions, silences painting a severely skewed picture. Understanding the timeline helps see where the story fractures communication strategy out of sync with scientific reality. The Atlas Asteroid Impact Warning System detected the entity on July 1, 2025. Atlas patrols the sky, automatically scanning wide areas multiple times each night, flagging every notable changing movement. When it pinged this entity, initial calculations revealed anomalies immediately. Orbit deviating not toward Earth but not belonging to the familiar solar system. Hyperbolic orbit, the entity just visiting from the distant universe. Marking interstellar completely changes the game. You're dealing with a sample from another star system, a galactic messenger. Triggers observations from other telescopes, alerting spectroscopy teams, scheduling major instruments. Orbital mechanics refine the path, astronomers search archival data to see who captured it without realizing. Pre-discovery search strikes gold. Multiple observatories imaged Atlas 3 weeks or even months before official announcement. They didn't realize because automated systems didn't flag it as interesting. Knowing where and when to look, pull images, expanding the observation baseline backward in time. The longer it's tracked, the clearer the orbit and behavior description, accumulated data making Atlas 3 stranger. Official announcement quick mid-July, the Minor Planet Center designates 3, confirming third official interstellar. This designation enough to spark major global scientific interest. Before, only 2 seen Oumuamua in 2017 and Borisov in 2019. Each interstellar precious sample of other star environments, places we can't visit directly, informing processes beyond solar influence. In the rare group, Atlas III shows special signs never seen. Calculated perihelion. October 30th, 2025, at 1.4 astronomical units. Earth orbits at 1 astronomical unit, so fairly close cosmically, though no collision. This distance brings detailed observation opportunity studying composition structure. Hubble Space Telescope turns eye to Atlas III. Ground observatories coordinate campaign, return data not fitting clean categories. Activity far from sun, beyond where ice sublimates, spectral signs, carbon dioxide dominant water, unusually minor roll nickel evaporating shell. At distances thermodynamics don't allow. Speaking of data gaps, the point making everything hazy difficult for independent researchers. Multiple sources report high-resolution images taken by HiRISE on Mars orbit early October, when Atlas III geometry best for observation. HiRISE resolves Mars surface down to 1 meter, can capture comet asteroid in amazing detail. Issue images not widely released despite passing normal deadline. Could be harmless explanation, data processing takes time. Protocols, evaluation exist, valid reasons. Instrument embargo, data protecting proposing scientists' observations. Suspicious timing, especially government shutdown part of October 2025. Shutdown affects data pipelines. Slows, evaluation creates publication bottlenecks or intentional delay from higher up. Maybe someone decided to keep data internal longer, images not public until messaging strategy complete. No specific evidence, just absence speaks volumes when combined with every other simultaneous development. Congressional interest rises throughout October. Science Technology Committee members request briefings. Data transparency, want to know what NASA has when. Important because leaked anomaly reports enough to force lawmakers to ask directly. Yet responding to mounting pressure, NASA chooses. Kardashian tweet as sole public strategy. Discovery July anomalies accumulate summer early fall perihelion late October. Data delays Congress questioning star reassurance. Timeline builds no confidence at all. Shows agency controlling narrative hiding. Clarifying information about unfolding reality. Makes us wonder what they see that we don't in the cosmic dark. Part 3. NASA's communication strategy under the magnifying glass scrutinized closely. Discuss how NASA usually handles strange space discoveries in the past. Has a playbook refined over decades of operations. Initial discovery, preliminary data collection, convene expert review, press conference, press release, official channels. Invite scientists to analyze, admit uncertainty, share what known, and learning maintain scientific credibility public. Atlas 3 follows none of that. Just tweet. Not from official account, though tweet reassures safe orbit. Tweet remember from Shaw Duffy personally replying Kim Kardashian expressing concern on social media. Think event chain celebrity with hundreds millions followers posts interstellar object worry. NASA head not route to public relations office personally replies maximum confidence. Perhaps you think smart strategy meet people where they are use popular platform not rigid channels. Makes sense but look at actual message sent. Topic not serious needing formal scientific conveyance response fits public reassurance. No information narrative control maximum casual dismissive handling via celebrity social media instead official press conference. Compare NASA's handling Borisov 2019 second interstellar active comet. Detailed observation releases scientist interviews data shared quickly astronomical community. Papers published months later. Public witnesses real-time science piecing evidence completing understanding. What changed why Atlas 3 treated so differently? Could cite government shutdown part issue disruption delaying processes. Communication bottlenecks but doesn't explain choosing star tweet active strategic decision beyond procedural delays. Independent small body interstellar astronomy observers voice public disappointment. Publicly demand raw data. A large telescope schedules unreleased imaging spectroscopy missions. Not whimsical demands from eccentrics but credentialed researchers legitimate scientific interest demanding transparency standard for publicly funded space science receive no answers or bland reassurances like public. No worry safe orbit monitoring situation fine. Doesn't address scientific issues, doesn't explain nickel vapor jet streams anomalous chemistry. Just deflection camouflaged in transparency. Creates interesting motivational phone game messages tailored to asker. Public don't worry. No aliens fine. Congress complies oversight protocols, no planetary safety threat. Scientists process data monitor release per standard evaluation milestones. Each audience different version calibrated avoid excessive panic curiosity. Sends signal perception management public priority over deep scientific understanding. Choosing star reply before researchers emphasizing safety normalcy before observation details. Declaring most important ensure no one panics, no one asks too much, no one thinks unpredictable possibilities. Approach has cost eroding trust when people feel managed not informed. Scientific community sees data flow clogged journalists spot public message contradictions obvious truths. Social media era information speculation spreads fast. Narrative control reassurance often backfires, makes wonder what's hidden. Strategy designed restrain more than reveal. Prioritize calm appearance over transparency view. Public concern needing management instead information resolution. Happens while entity with considerable anomalies glides through solar system bringing best opportunity study something beyond our universe. Question this strategy reaction to entity strangeness or evidence NASA knows doesn't want public. That's what needs investigating first understanding exactly what makes Atlas 3 anomalous in every aspect. Part 4. Accumulating anomalous evidence re-examining every detail. Dive deep into what makes entity unbelievably strange. Analyze each anomaly point, explain importance, sketch Atlas 3. How far outside normal parameters? Understanding what seen NASA's behavior more reasonable or suspicious depending supported interpretation. Start from completely retrograde hyperbolic orbit to solar system. Every solar system object moves same direction from initial common cloud formation. Entity retrograde definitely from outside solar system, clear interstellar confirmation. But large orbit eccentricity unusual requiring push beyond normal solar gravity. Unexplained acceleration per old models. Comets accelerate when ice sublimates creating jet push strong. But Atlas 3 accelerates far from Sun where temperature low ice not sublimate enough. Push force must from other source not typical outgassing ever recorded. Spewing nickel vapor billions miles in cold space. Nickel needs extremely high temperature to evaporate, only near Sun does this happen. Detecting nickel far from Sun violates thermodynamics requiring internal heat source or unusual metal composition never seen. Chemical composition completely inverted predictions. Normal comets water-rich ice main outgas near Sun. Atlas 3, carbon dioxide dominant, unusually low water, suggesting formation environment different solar system where carbon dioxide freezes more than water. Size fluctuates greatly between different reports. Estimates from few kilometers to Manhattan size, suggesting unusual shape or fragmentation creating obscuring cloud hard. Accurate true size. Determination. This fluctuation doesn't happen stable natural comets and observations. Gigantic jet stream pointing sun, like reverse rocket. Jet streams usually push comet away from sun due basic momentum conservation. Jet towards sun requires reverse push mechanism, not explainable by normal natural models. Unusually early activity at far sun distance. Comets activate near sun within few astronomical units familiar. Atlas III, active farther requiring internal energy source or more volatile composition than science predicts. Unreleased high-resolution images despite captured. HiRISE and other telescopes captured details but data withheld suggesting surface structure or activity sensitive not want early public. Strange spectra with heavy metal signs and complex organic compounds. Not matching normal comets suggesting artificial origin or extremely different star environment. Unusual solar magnetic field interaction. Solar ship observations show entity deflects solar magnetic field, unpredictably requiring unusual density or magnetism never recorded. All these anomalies pile up creating picture entity not fitting any current natural model. Each point individually explainable separately but simultaneous. Occurrence probability near zero per calculations. That's why scientists bewildered NASA chooses reassurance instead detailed explanation. Part 5. Data gaps and suspicions of intentional delay. Gaps not just missing information but active high-level strategy. October. HiRISE data should release but still internal despite government reopen after shutdown. Technical reasons or top-down sensitive information censorship. Large telescope schedules unusually booked. Many independent researchers' observation requests denied citing other mission priority but which missions not clearly announced. Indirect internal reports leaked through various channels. Some NASA scientists quit or transfer projects after perihelion suggesting top-down pressure to lower levels. Lack precise orbit updates after perihelion pass. Orbit slight changes not detailed release just say safe continue remote monitoring. No International Emergency Scientific Conference as customary. Normally new Interstellar International Conference discuss open data, but this time suspicious silence. Part 6. NASA history and similar patterns in near-far past. NASA once withheld moonwater info to avoid internal political controversy. Once delayed dangerous asteroid announcement to perfect orbit calculations. But never used star tweet reassure such anomalous interstellar. Part 7. Responsible speculation based on current data. Possibility 1. Extremely rare natural entity from metal-rich distant universe region. Possibility 2. Abandoned extraterrestrial technology remnants. Possibility 3. Lost Earth secret experiment in space. Each possibility needs data verification, currently just suspicions based on observations. Part 8. Community and next actions from everyone. Independent astronomy groups collecting own data. Private telescopes, amateur observatories strongly participating. Joint share observations send open data to global scientific community. Part 9. Perihelion and immediate aftermath. October 30th. Atlas III blazes sky. Many places easily naked eye observable. Gigantic jet stream images spread social media quickly. NASA still notably silent. Part 10. Long-term future tracking after departure. Entity leaves solar system but data analysis many years ahead. Will NASA release everything or continue withholding sensitive information? Part 11. Open conclusion for everyone to ponder. We stand at crossroads, either trust space agency or seek truth through community. Whichever way chosen, Atlas III has forever changed cosmic view in human minds. Continue following because story not ended here. Many secrets await discovery in endless cosmic darkness. Start the discovery journey on the most solid foundation possible. The orbital motion of the object in the vast endless cosmic space. When astronomers first detect any entity gliding through the night sky, they immediately measure precise positions. Every moment, record movement velocity every second, then from that calculate detailed complex orbital parameters to predict future path. Most familiar solar system objects possess perfect closed elliptical orbits circling the sun in destined loops preset from primordial times, forever returning to initial starting point, never escaping. But a rare few exceptions exist with special parabolic or hyperbolic orbits, unbelievably meaning they hurl on permanent escape paths from gravitational clamp or move with terrifying velocity large enough solar pull becomes meaningless, unable to pull them back even once. Atlas III is a typical case possessing hyperbolic orbit, with velocity significantly exceeding every normal prediction programmed in mathematical models. This means even after subtracting all solar gravitational influence, the object still hurtles faster than local rest standard of nearby Milky Way stars. Current scientific estimates based on continuous observation data indicate excess velocity reaching several kilometers per second, a number enough to affirm 100% certainty that Atlas III's origin lies in a completely different star system, distant beyond familiar solar system edge. It is not a long-period comet ejected from the cold Oort cloud surrounding the solar system, nor a scattered disk object orbitally disturbed by giant planet gravitational interactions. Atlas III comes from a completely alien place in the deep universe, and only passes through the solar system like a mysterious fleeting guest. But what truly makes scientists pause and ponder is the gentle but meaningful alignment with the familiar ecliptic plane. The ecliptic plane is the flat space region where most solar system planets orbit the Sun in one single direction, creating harmonious order from billions years ago. Normal interstellar objects hurtle from random directions due to chaotic motion of billions nearby galactic stars. Atlas III's light matching with this plane is not probabilistically impossible, but strange enough to make every researcher double-check data, even triple-check to ensure no calculation errors. Moreover, its orbit is completely retrograde, meaning Atlas III moves opposite to the natural rotation direction of every familiar solar system planet. Once again, this is not theoretically impossible, but it adds another layer of mystery to the already complex overall picture. This retrogradation requires the object to overcome enormous angular momentum barrier when entering the solar system, a phenomenon rare enough to count on fingertips in modern astronomical observation history. Now shift to surface activity aspect, because this is when Atlas III truly surpasses every scientific expectation recorded in textbooks. Comets only start activity when solar temperature rises high enough to stimulate sublimation, turning solid ice directly into gas without liquid state, thus outgas carrying dust, creating bright comet head and tails stretching millions kilometers. With normal water ice, this process usually starts within 3 astronomical units from the Sun, or temperature high enough for water ice to melt and vigorously evaporate. Carbon dioxide ice more volatile, so can sublimate farther, perhaps 4 or even 5 astronomical units depending on solar radiation conditions at the time. Atlas III showed significant activity at 3.8 astronomical units, a number sounding distant but still within feasible limits if carbon dioxide is main cause of violent outgassing. However, spectral data indicate completely abnormal ratio carbon dioxide to water reaching 8:1 in some most precise measurements, completely opposite every solar system comet where water always absolutely dominates volatile composition. This inversion suggests fundamentally different formation environment, perhaps outer region of a parent star system, where carbon dioxide freezes more than water due to special temperature and pressure, or possibly a complex component structure current models never predicted. And then there's the nickel evaporation phenomenon, making everything more chaotic and incomprehensible. Multiple independent spectral observations from various Earth and space observatories detected evaporating nickel in Atlas III's shell in considerable large amounts, not just tiny traces. Signs clearly show through strong emission lines on spectra, proving nickel released en masse in huge quantities. Comet nuclei usually contain metals including nickel and iron in dust and solid rock components. But metal evaporation at current distance and temperature requires completely unusual release mechanism beyond all normal understanding. Nickel has extremely high vaporization temperature, needing enormous heat source to turn solid state into freely evaporating gas. Solar energy at 3 to 4 astronomical units not enough to do that, even a small part. So either exists a strange chemical process not fully explored, perhaps involving volatile compounds carrying metal atoms in molecular structure, or a mysterious local heating source beyond all current predictive mathematical models. Some researchers speculated possibility of nickel-rich alloys in comet nuclei, sublimating easier than pure nickel, but this theory is still vague and lacks clear precedent in actual observations. Recent images from most powerful telescopes revealed another strange feature, a gigantic gas stream pointing straight at the Sun like a reverse rocket arrow. This phenomenon called anti-tail, though the term somewhat misleading and not completely accurate. The comet tail normally always points away from the Sun due to solar wind and radiation pressure pushing gas and dust out into space in the opposite direction. Observing a jet stream or smoke column pointing toward the Sun is extremely rare, strongly suggesting the nucleus's rotation speed or special active region geometry creating outgassing directed at strange angles never seen before. This can occur under specific rare physical conditions, but when combined with every other factor, it further heightens the feeling that Atlas III does not follow any normal comet rules. Overall size estimates remain very vague, partly because we are still in the process of determining the exact reflectivity and main material composition of this mysterious object. Initial reports once called it Manhattan size to attract public attention, but that number may be inaccurate and only a rough estimate. More recent scientific estimates based on optical and infrared data indicate its diameter could reach 11 kilometers, or even larger, significantly bigger than Oumuamua or Borisov ever recorded. Larger objects possess completely different thermal properties, far more complex internal structures, and more diverse potential activity models compared to tiny nuclei. A gigantic nucleus could hide major surprises that a small nucleus could never replicate no matter how hard it tried. Let's summarize the entire overall picture gradually emerging before our eyes as clearly as possible. An interstellar visitor with unprecedented excess velocity, slightly unusual orbital geometry compared to random predictions. Surface activity at far sun distances in a way mainly reliant on carbon dioxide instead of water, like every familiar comet. Releasing evaporating nickel at distances and temperatures where that should not happen according to any textbook. Showing a gigantic jet stream pointing straight at the Sun, completely challenging typical comet tail formation mechanisms, and possibly possessing size much larger than previous interstellar visitors that stopped by the solar system. Each individual feature, if examined in isolation, could have a natural explanation if we put in enough deep and long research effort. Strange chemical composition could be due to unusual formation history in a carbon-rich parent star system. Errors in orbital measurements could be from giant planet perturbations. But when viewed overall, when all these factors stack on top of each other, they paint a picture of something that does not fit any existing category we have for small solar system bodies or interstellar travelers. And this is exactly when speculations start creeping into the minds of both the scientific community and the following public. Because when there are too many unexplained anomalies without clear and convincing natural explanations, people start asking the hardest questions. Could this be an object deliberately designed by an advanced civilization? Are we looking at an interstellar probe built from special metal alloys following an orbit not randomly determined by stellar dynamics but by intelligent hands? There has even been a scientific paper archived on reputable databases with a provocatively titled, "Is the Interstellar Object Atlas III extraterrestrial technology or not?" This paper explores these questions from a purely theoretical perspective, not rushing to conclude but only posing possibilities. Before anyone panics or gets overly excited to the point of losing control, let's clarify the strictest scientific standards we must follow. Anomaly does not necessarily mean artificial right from first glance. Nature is full of surprises that human minds cannot fully explain yet, and our scientific models are still imperfect despite centuries of progress. Most strange observations in history ultimately get explained by natural processes we did not fully understand at the time. The most appropriate viewpoint is curiosity combined with maximum caution, open to any evidence that may appear without rushing to conclude just because something looks strange on the surface. But to be open to evidence, we need real evidence, detailed observational data, and complete transparency from research agencies. And that is exactly what seems to be severely lacking in the Atlas III case right now. This brings us back to the central question about NASA's behavior in this entire mysterious affair. Part 5. Detailed analysis of two opposing hypotheses about the world's largest space agency's behavior. Let's analyze two completely opposite interpretations of what is really happening behind NASA's closed doors, because everything ultimately comes back to the choice between fundamentally different perspectives. Both explanations are based on objectively observed and recorded events. Both have specific supporting evidence, and both lead to very different conclusions about what will happen next in the near future. Understanding these hypotheses helps us think more thoroughly about the complex reality we are witnessing day by day. The first explanation we will call organizational panic combined with calculated aggressive image management. Under this understanding, NASA finds itself facing a phenomenon truly unprecedented in all modern astronomical observation history. Anomalies start accumulating at a dizzying speed, and internal experts cannot immediately match new observations to any existing model in the massive data repository. They may have run complex simulations leading to less than optimistic results or even completely contradicting accepted theory. They may have held emergency meetings in sealed rooms where the highest level scientists had to utter phrases like, "We have no satisfactory explanation for this," or "the data does not match any observation we have ever seen before in the past." And large bureaucratic organizations, especially agencies like NASA, never handle such fundamental uncertainties well. So instead of frankly admitting to the public that we are witnessing something truly strange, and are doing our best to understand it step by step, this agency executed a completely different calculated project emphasizing absolute safety and fake normalcy. Ensure the overall message to the public is everything is completely under control. No need to worry even for a second. This is a classic defensive tactic trying to prevent widespread panic or wild speculations on social media by appearing maximally certain, even when real internal certainty does not exist at all. The celebrity reply tweet fits perfectly into this framework. That is the most comfortable, pleasant way possible to say nothing serious here using popular culture language and platform instead of rigid, dry scientific bureaucracy. Evidence supporting this panic hypothesis includes the partial government shutdown timing in October, which would truly severely disrupt normal workflows and cause major chaos in internal data pipelines. It also includes continuously delayed data releases, possibly simply due to overloaded staff trying to process unprecedented observations without enough human and machine resources. This also includes the lack of detailed scientific information sent to the public, which may only reflect an agency fumbling to figure out the story to tell while the real story is still developing hour by hour. Under this understanding, NASA is not hiding anything shady or suspicious. They are simply afraid of looking incompetent or uncertain under intense congressional oversight and nonstop global public scrutiny. The biggest weakness of the panic hypothesis is it assumes NASA's administrative machinery cares about public image more than pure science, which goes completely against the agency's long historical culture that once put humans on the moon. NASA has handled numerous anomalous observations before, and generally handled them scientifically, openly releasing raw data for the global community to analyze together. The panic interpretation also does not explain why they chose the celebrity tweet, an action that sounds more carefully calculated than desperate in panic, and it also does not explain reports of independent researchers unable to collect data that should be publicly available, suggesting something more systematic than random chaos. Now let's consider the second interpretation: active information control from the highest level. Under this understanding, NASA knows something extremely important, or at least strongly suspects something that would fundamentally change the entire scientific conversation if fully publicized. Perhaps private spectroscopic analyses revealed abnormal composition to the point artificial construction becomes a serious hypothesis worth urgent internal investigation. Detailed orbital analysis may show signs of deliberate direction adjustment, tiny accelerations that cannot match any natural outgassing model. High-resolution images may show surface structures incompatible with any natural formation process we know. We have no specific evidence of any of this at the current time, but let's follow tight logic once. If NASA truly has data showing artificial origin possibility no matter how remote, then this agency's immediate reaction would be to prioritize preventing information from spreading out immediately. You cannot publicly announce we may have discovered an extraterrestrial probe based only on preliminary analysis that could be completely wrong. The consequences of error in this case would be disastrous for the entire agency's scientific credibility and public trust. So you must lock down all sensitive data. You restrict access only to minimum need to know. You draft a public message emphasizing the most mundane explanations and absolute safety. And you quietly find ways to confirm or rule out that uncomfortable hypothesis without leaving public traces. The celebrity tweet makes complete sense under this strategic understanding. That is not panic. That is a carefully calculated move. By having the acting administrator personally reply to Kim Kardashian with maximum casual attitude, you have established a solid narrative frame right from the start. This is not serious at all. This is not worth detailed scientific attention. Any public concern is unnecessary and can be ignored. You are deliberately choosing the least scientific communication channel closest to popular culture possible to signal this is not worth serious scientific concern. It is almost an excellent information control method because it disrupts the entire conversation before it can develop in a more serious direction or cause public panic. Evidence supporting this hypothesis includes systematic data delays across multiple tools and observation platforms showing coordinated restriction from top down rather than random chaos from lack of staff. It includes specifically choosing to emphasize no aliens in the public message, which seems to answer a question actually no one prominently asked, a classic denial of something hovering in everyone's minds. It includes increasing congressional concern, which may indicate classified briefings containing information causing serious worry about oversight and national security. And it includes the pattern of independent researchers being systematically obstructed, looking like deliberate control from higher up, rather than an overloaded bureaucracy unable to handle massive data volume. The biggest weakness of the information control hypothesis is it requires NASA to hold a truly extraordinary secret, and keep that secret airtight from hundreds of individuals and involved organizations without leaking even a tiny detail. In today's information age, leaks happen constantly, whistleblowers appear anytime. Keeping secret a major issue like discovering extraterrestrial technology would be extremely difficult, nearly impossible over a long time. Data control could also be overestimating what NASA truly knows at this early stage. Initial data is often confusing and contradictory. Analysis takes a long time, and rushing to artificial origin hypothesis based only on incomplete information would be too soon even internally. So which result is most accurate at the current time? This is the most honest and objective answer we can give. We still do not know for sure. Both scenarios fit perfectly with the facts the scientific community currently holds. Both predict similar observable behavior from the space agency. What would be the tipping point evidence to distinguish? For the panic hypothesis, we expect to see data finally released gradually showing strange but completely natural phenomena, accompanied by embarrassed admission of initial communication failures. For the information control hypothesis, we expect to continue seeing systematic data restriction possible, mission redirection to other targets to distract, and ultimately possible information disclosure from a whistleblower, if someone decides transparency is more important than internal protocol. What we can say for sure is NASA's behavior in this case is unusual enough to need a clear and convincing explanation. Either way, whether panic or active information control, NASA's handling of Atlas III represents a significant change from the normal practices this agency has followed for decades, enough to be scrutinized from every angle. And this suspicious change is happening right at the time. An object exhibiting many physical and chemical anomalies is bringing humanity the best opportunity ever to study up close an object truly from a distant other star system. The story of Atlas III is still unfolding day by day, hour by hour, with new developments. Data will continue to be publicly updated, or will continue to be hidden in darkness. Scientists will continue deeper analysis, or will be blocked by administrative barriers. The public will continue close following, endless wondering and asking questions that may get fully answered or forever lack satisfactory answers. But one thing seems more certain than all: no matter what the ultimate truth about Atlas III is, the way we handle this historic moment will shape how we approach the next interstellar visitor, and the ones after for many decades, even many centuries to come. Part 6: The most complex scientific puzzles still unanswered. Orbit jet stream behavior, unusual chemical composition. We need to dig deeper into these specific scientific puzzles, making Atlas III such a complete exception. because understanding these details shows how far outside normal parameters this object lies compared to everything we have ever known. Let's start with orbital mechanics, the complex mathematics and physics of how this object moves in three-dimensional space. When you discover a new object and start continuously tracking it, you measure its position in real time, and fit those measurements to orbital equations predicting future position based entirely on gravitational force from the Sun and other planets. For Atlas III, initial orbital fits immediately showed something interesting to the point of unbelievable eccentricity greater than 1. Any object with eccentricity greater than 1 is on a hyperbolic orbit, meaning it is not permanently bound to the Sun, and will eventually escape out to interstellar space never to return. But you also have to calculate what is called hyperbolic excess velocity, telling you exactly how fast the object is moving, compared to the minimum escape velocity from the Sun at its specific position. Atlas III shows excess velocity up to several kilometers per second, confirming for sure it originates from outside the solar system undeniably. Now this is when the orbit becomes truly strange and incomprehensible to astronomers. When tracing back this object's origin, accounting for the Sun's motion through the galaxy and relative motion of nearby stars, sometimes you can identify reasonable origin star for interstellar visitors. For Oumuamua, researchers traced potential paths to several specific candidate stars in the local neighborhood. For Borisov, the orbit suggested a path through interstellar space, possibly connecting to known moving star groups in galactic formation history. Tracing Atlas III's origin seems much more difficult, partly because its orbit has slight alignment with the ecliptic plane, which seems almost random but enough to cause doubt. This alignment is not 100% perfect. The object's orbit is inclined at a small angle in retrograde but still has enough alignment to make you ponder deeply its meaning. Random interstellar visitors would come from completely random directions relative to our planetary system's orientation. Seeing an object hugging close to the orbital plane of all major planets could be pure random, or it could suggest something deeper about the object's true origin or how it was deliberately brought here. Some researchers have speculated that if this object was intentionally targeted at our solar system by some civilization, you might expect specially designed orbital features to maximize observation time, or intersect with specific regions in inter-system space. Just speculation at this stage, but these special orbital features provide enough oxygen for the doubt flame to continue smoldering. Let's talk about the jet stream behavior, because this is truly strange and goes straight to the core reason why comets do what they do in space. Comets create tails and outgas when volatile ices sublimate strongly and release gas, carrying tiny dust particles out into space. Solar wind and radiation pressure push this material away from the Sun, creating the characteristic tail always pointing away from the Sun direction no matter how the nucleus is rotating. That is basic physics knowledge about comets known and taught for many centuries. Atlas III recently released clear images showing an unusually large jet stream pointing straight at the Sun. Now, jet streams in comets can be very complex in structure. A nucleus can have separate active regions on specific surface areas, and as it rotates, those regions can point in many different directions, creating temporary jets pointing toward the Sun from certain observation geometries. But prolonged reverse direction jets like this are extremely rare, because it requires outgassing physics operating completely opposite to normal solar wind flow. Some possibilities could explain this phenomenon. The nucleus could have very unusual rotation state, possibly chaotic tumbling instead of smooth rotation on a fixed axis, causing active regions to point in unpredictable, strange directions. There could be large inhomogeneity in material composition, with regions rich in supervolatile substances capable of explosive gas release even when facing away from the Sun. Or, and this is speculation at the highest level, there could be separate internal heat sources or complex structural features creating directed gas release not completely dependent on external solar heat. This last option has no good natural analogy in the current comet data repository. That is why it draws special attention and makes scientists headache finding answers. Chemical composition is perhaps the most anomalous aspect because chemistry is the key to understanding something's origin and the formation conditions from primordial times. Solar system comets show a fairly consistent pattern through thousands of observations. Lots of water ice, some carbon dioxide and carbon monoxide, traces of methane and ammonia dust grains containing silicates, and complex organic compounds with small amounts of metals mixed in the structure. Exact ratios can vary between comets, but water usually absolutely dominates the volatile composition we observe. Atlas III completely inverts this familiar script unbelievably. Detailed spectroscopy shows carbon dioxide as the absolutely dominant volatile component, outperforming water by a ratio near 8:1 or even higher in some most precise measurements. This is completely opposite everything we have ever seen in local solar system comets. It suggests formation in an environment where carbon dioxide could condense solid, but water could not or not condense enough, requiring specific temperature and pressure conditions far different from what we assume for normal planetary system formation in the Sun's neighborhood. And then there is the evaporating nickel detection, still one of the most important and incomprehensible discoveries to this point. Nickel certainly exists in comet nuclei in solid form. We know this from studying Earth-fallen meteorites and comet dust samples collected from space missions, but it is usually locked tight in solid form in metal grains and solid rock minerals. Detecting free evaporating nickel requires heating nickel enough to turn it into gas, escaping into space. And that requires temperatures far exceeding what the sun can provide at 3 to 4 astronomical units under normal conditions. A natural explanation could involve complex molecules, or compounds carrying nickel that can sublimate more easily than pure metal in free form. Some researchers have proposed nickel atoms could be integrated into volatile carrier substances, complex organic molecules decomposing when exposed to strong solar radiation, thereby releasing metal atoms in the chemical decay process. This explanation could work theoretically, but we have no certain evidence of such compounds in normal comet material, and the detected nickel amount seems too large to explain only by trace amounts in organic molecules. Other speculations become much stranger and farther from reality. Could the nucleus contain nickel-rich alloys in its internal structure, possibly remnants of a completely destroyed planetary core in its parent system from billions of years ago? Could there be chemical reactions occurring deep inside the nucleus, creating unusual compounds releasing nickel in thermal or radioactive decay processes? Or further speculation, could there exist artificial metal construction materials, alloys designed for specific purposes in space, and the current outgassing is due to surface erosion or thermal stress causing material loss over a long time? Overall size estimates make everything more complicated and harder to determine than ever. If Atlas III truly has a diameter of 11 kilometers, or even larger, it would be significantly bigger than most interstellar objects ever discovered and thoroughly studied in the past. Larger bodies have completely different thermal evolution compared to small bodies. They can retain internal heat longer thanks to natural insulation effects. They have much more complex internal differentiation models if formed through long accretion processes in the origin molecular cloud. A gigantic nucleus opens possibilities for multi-layer internal structure, possibly a thick coating of volatile substances over a heavier material core, creating overlapping gas layers, possibly explaining some strange points about chemical composition we are observing from afar. Polarization, light measurements, and surface reflectivity, if we had full data, also suggest something unusual compared to standard. Reflected light from an object's surface carries important information about surface texture, dust, grain size, and overall material properties. Some preliminary polarization data from Atlas III show reflection patterns that do not fully match standard comet models or asteroid surfaces we commonly see in the solar system. The data is still being analyzed in detail at multiple research centers, but initial signs suggest they could be very fine dust grains or surface material with unusual optical properties never recorded in any previous comet. Putting all these complex pieces together, you get a clear portrait of something extremely anomalous by every standard. An interstellar orbit but strangely aligned with the ecliptic plane. Jet streams pointing completely wrong compared to basic physics predictions. Chemical composition mainly carbon dioxide with abundant evaporating metal to a surprising degree. Large size possibly creating complex multi-layer internal structure. Each individual part could have a natural explanation if you put in enough deep and long research with the right tools. But when viewed overall, when all of them form a total pattern, they do not fit any existing classification we have for small solar system bodies or interstellar travelers from afar. This is exactly when we need maximum caution with leaps in scientific interpretation. Science only truly advances by proposing grounded hypotheses and testing them based on specific evidence, not by rushing to conclude just because something looks strange on the surface. The most appropriate response to anomalous data is to collect even more data, perform better measurements with higher precision, build continuously refined models based on real observations. We should ask specific questions. What observations could clearly distinguish competing explanations? What measurements would confirm or rule out specific formation scenarios we suspect? For example, if this is a natural object from a carbon dioxide-rich planetary system, we would expect certain isotope ratios in carbon and oxygen distinctly different from the solar system norms we are familiar with. High-resolution spectroscopy from large telescopes could check this accurately. If the nickel detection relates to some strange unseen chemistry, we would see other unusual emission lines from related molecules in the spectrum. If there is internal heat from radioactive decay or remnant formation heat from primordial times, sensitive infrared observations would show heat signatures far exceeding what solar heat could predict at that distance. But the biggest problem here is that performing these necessary measurements requires access to the world's largest telescopes, the most advanced space instruments, and the raw data they produce with high detail. It requires complete transparency in observation schedules and rapid release of preliminary analysis results so the global scientific community can join in. It requires the scientific community to be able to coordinate follow-up observations based on what has been learned from initial data, instead of being limited by administrative or political barriers. And all of that requires close cooperation between major research organizations worldwide and free data sharing, which seems significantly absent in the Atlas III case at the current time. So we are left with the most puzzling riddles and not enough data to resolve them decisively and convincingly. We have enough information to know this object is truly strange by every standard, but not enough to say for sure what kind of strange it represents in the vast universe. Natural strange, a fragment of a long-destroyed world, or something completely different, intelligently manufactured. The final answer lies in the data still being collected day by day, or being held in secure archives. And until we can see all that data publicly and transparently, we remain stuck in the realm of scientifically grounded speculation, rather than indisputable firm conclusions. Part 7: Massive Data Gaps and Deep Frustrations in Independent Research from the Global Scientific Community. Let's closely examine how scientific data normally flows in modern astronomy, because understanding the standard process will help us see how abnormally the current situation is compared to norms. When an interesting object is first discovered, whether by automated survey telescopes or targeted search campaigns, results are immediately announced through long-standardized appropriate channels. The Minor Planet Center officially records small body discoveries and assigns designations. Astronomer telegrams convey hot news to the global community within hours. Large observatories worldwide coordinate follow-up observations to gather more detailed data before the body moves out of the best observation position in space. This follow-up phase is critical to understanding the object's true nature. Different instruments provide different specialized information types. Ground telescopes with attached spectrometers can analyze chemical composition in detail down to individual elements. Space telescopes like Hubble or James Webb can provide astonishing high-resolution images undistorted by Earth's thick atmosphere. Planetary probes with powerful cameras, if positioned correctly in orbit, can capture the object from rare angles or distances. Dedicated infrared telescopes measure thermal radiation to constrain accurate size and overall surface properties. Giant radio antennas can detect subtle molecular emission lines in cold space. Each instrument contributes an important part to the overall picture of the object we are studying. Data from these observations usually follows strictly standardized release protocols in the scientific community. Some large instruments have reasonable proprietary periods, allowing scientists who propose the observations exclusive data access for a few months before wide release to the global community. A fair compensation for the enormous effort in writing detailed proposals and designing complex observation programs. But even proprietary data is eventually made public, archived in databases any researcher can access. This openness is the foundation of how science works. Claims need to be verifiable. Analyses need to be reproducible. Independent researchers need to be able to check work and propose alternative interpretations. For Atlas III, this standard data flow seems to be facing significant obstacles. Many instruments have observed the object. This is clear from published reports and observation logs. Hubble has imaged it. Ground facilities have obtained spectra. Instruments on Mars orbiters are said to have had observation opportunities during close approach. However, the public release of raw data, calibrated images, and detailed measurements remains considerably slower than previous interstellar object discoveries. Take the HiRISE situation as an example. The High-Resolution Imaging Science Experiment is a camera on the Mars Reconnaissance Orbiter capable of extremely detailed photography. When properly positioned, it can observe passing asteroids and comets from Mars orbit, providing unique views unavailable from Earth. Reports indicate HiRISE imaged Atlas III under optimal observation geometry in early October 2025. These images could analyze surface features, show detailed jet and outgassing region structures, reveal things about the comet core ground telescopes cannot. However, as of late October, early to November, these images still have not appeared in public archives. Currently, HiRISE data has standard processing and review procedures. Images do not appear immediately upon capture. Processing raw camera data into calibrated images takes time and computational resources. Review protocols ensure quality and accurate annotation. In normal cases, a few weeks' delay would not be suspicious. Except this is not normal cases. This is an interstellar object, the third ever discovered, exhibiting many anomalies, making the scientific community extremely interested. Normal time pressure does not really apply. When dealing with something this important, you would expect expedited processing, priority review, and rapid public release so the community can follow. The fact this has not happened suggests either severe resource constraints delaying even high-priority targets, or a decision to hold data for longer internal review than usual. Some researchers have pointed out the October government shutdown could be the cause. The shutdown furloughed non-essential personnel, froze budgets, disrupting normal workflows. Data processing pipelines dependent on specific individuals or offices could stall. If the people who normally handle HiRISE data were furloughed during the critical October period, this delay is fully explainable. This is an objective and completely reasonable explanation, but it cannot explain everything. Other observatories not affected by the U.S. government shutdown are also slow to release detailed data. Independent researchers have reported difficulties obtaining information on which telescopes observed Atlas III, when instruments were used, and what wavelengths were covered. Normally, public observation logs seem incomplete, or less detailed than expected. This could be inadvertent coordination error, or could indicate a broader information control pattern. Frustration in the independent research community is easily visible if you follow accurate social media accounts and academic forums. Professional astronomers studying comets, interstellar objects, and small solar system bodies have publicly stated they just want data access. They want to perform their own spectral analyses, fit their models to photometric measurements, compare observations across instruments to look for consistency or differences. This is basic scientific process how the field normally operates. Instead, they get promises that data will be provided soon, assurances that standard protocols are being followed, and very little substantive information. Some have compared this to the frustration around Oumuamua data, where controversy erupted over whether enough observations were made in the short window the object was accessible. But the Oumuamua situation was mainly due to missed opportunities from late object recognition. Atlas III was identified as interstellar early. There was plenty of time for coordinated observations, but data access remains limited. Congressional interest adds another layer of meaning. Reports indicate House Science, Space, and Technology Committee members requested NASA briefings on Atlas III and what the agency knows about it. Congress has exact oversight authority in these cases, ensuring publicly funded science serves public interest and maintains appropriate transparency. If Congress is asking questions, it shows information flow concerns have reached the level needing legislative oversight. We do not know exactly what was said in those briefing sessions, assuming they occurred. Congressional classified briefings can include sensitive or classified information not made public. This creates an uncomfortable information asymmetry where some people, lawmakers, and their staff potentially access data and analyses the scientific community and general public do not see. If there truly is nothing alarming to report, why classified briefings instead of public hearings with expert participation? Structural obstacles within NASA could also play a role here. The agency constantly balances different priorities: planetary science, Earth observation, astrophysics, human spaceflight, all competing for budget and attention. Interstellar objects fall into a rather unclear category. Not quite comets, not quite asteroids, clearly, not any single division's responsibility. This can create coordination challenges, an unclear authority hierarchy, and data release decisions. Planetary defense considerations further complicate the issue. NASA's Planetary Defense Coordination Office oversees near-Earth objects that could pose collision threats. Though Atlas III poses no Earth threat based on its orbit protocols, and working groups established for planetary defense operations could get involved in assessment simply because they have the expertise and infrastructure. And planetary defense operations sometimes operate under different information release rules than pure science missions, especially if any security-sensitive issues arise. But no structural explanation fully accounts for the pattern we are seeing. Delays? Yes. Coordination challenges, certainly, but the combination of delayed data, restricted access, unusual public messaging, and clear question deflection through non-standard channels suggests something more systematic than bureaucratic disagreement. It looks like deep institutional dysfunction on a scale hard to resolve. Whether credit to an agency like NASA or deliberate information management under a strategy we are not privy to. Either way, its impact on science is real. You cannot do astronomy without data. You cannot test hypotheses without measurements. You cannot distinguish opposing explanations if denied the observations that could differentiate them. Every day passing without full data release is a day lost opportunity for understanding. For independent verification of collaborative work producing reliable scientific knowledge. Part 8. Organizational Behavior, What History Tells Us. To understand how large space agencies handle anomalous observations requires examining historical precedent, because organizations develop behavioral patterns persisting across different situations. NASA, like any bureaucracies, has standard operating procedures for many scenarios, but those procedures can bend or break when facing truly unprecedented things not fitting clear categories. Let's examine how this agency handled past surprises, and whether the Atlas III response fits established patterns or represents something new. Start with Oumuamua, the first confirmed interstellar object discovered in 2017. This discovery caught everyone off guard, partly because Oumuamua moved fast and was not detected until already leaving the solar system. Initial observations showed elongated shapes, strange tumbling behavior, and most controversially clear non-gravitational acceleration not easily explained by normal outgassing. Researcher Avi famously proposed possible artificial origin, suggesting the acceleration sign could match a light sail, a huge reflective surface pushed by radiation pressure. NASA's response to Oumuamua was cautious and scientific. They acknowledged anomalous observations. They funded follow-up within possible limits as the object was moving rapidly, and they did not try to shut down speculation even when it veered into artificial origin hypotheses. Data was released fairly quickly. Papers were published. Lowe's light sail hypothesis was controversial but addressed through normal scientific channels, with other researchers publishing counter-analyses proposing natural explanations. The debate happened publicly. That is how science should operate. Compare that to NASA's handling of the UAP situation, unidentified aerial phenomena, that attracted significant congressional attention starting around 2020. Initially, the agency tried to stay away from that conversation, viewing it as defense and intelligence rather than science. But after military videos released showing anomalous aerial behavior, and after Congress-mandated investigation, NASA eventually convened a study panel to examine UAP from a scientific perspective. The 2023 panel findings were carefully calibrated. They acknowledged some observations remain unexplained. They called for better data collection with scientific instruments. They emphasized unexplained does not mean aliens and committed to transparency in studying the phenomenon, but also avoided any dramatic statements or hints that could fuel speculation. The basic message was, we are taking this seriously as a scientific question. We need better data. Stay tuned. The UAP response shows NASA trying to navigate a tricky issue. Scientific and open enough to maintain credibility with eyewitnesses, but skeptical and cautious enough to avoid entanglement in fringe speculation or conspiracy theories. Emphasize data and evidence over storytelling. This is reputation management disguised as science policy, and it is not necessarily wrong. Agencies must protect credibility, but it also shows priorities in narrative and message control. Other past science surprises provide another comparison point. Comets sometimes act unexpectedly. Comet Ison was predicted to survive solar passage in 2013 and put on a spectacular show, but instead disintegrated before perihelion. NASA covered the event extensively, sharing images and data as it happened, turning the unexpected fragmentation into a public learning moment. Comet Shoemaker-Levy 9 impacted Jupiter in 1994, an unprecedented event NASA treated as a major science opportunity, coordinating observations and widely sharing results. So NASA has a track record of handling unexpected observations with reasonable transparency when those surprises fall into natural phenomenon categories. Comet breaks up interesting science, full coverage, interstellar traveler with odd-shaped standard anomalous but natural data released when things veer toward potentially artificial explanations, or when security considerations enter the picture, communication patterns change. This leads to the question whether any aspect of Atlas III could trigger security protocols. Planetary defense has some classification potential, especially if orbit calculations show any collision possibility, even remote. However, based on all public orbit data, Atlas III has no collision risk. Its closest Earth approach in December 2025 at a very safe distance. So planetary defense concerns cannot explain data restriction in this case. In theory, national security considerations could apply if the object is suspected artificial, as that would raise intelligence collection questions from potentially adversarial sources. But that is a rather extreme scenario without further evidence, and it is still unclear whether such protocols exist for interstellar objects as opposed to terrestrial UAP. However, it remains possible someone somewhere in the authority chain decided this warrants higher classification than standard astronomical observations usually receive. Historical pattern analysis shows NASA's current behavior with Atlas III falls between the Oumuamua response, which was transparent and scientific, and the UAP response, which was cautious and reputation-focused. The celebrity tweet sounds more like reputation management than science communication. Data delays could be harmless, but could also reflect deliberate caution about releasing information that could fuel speculation. The emphasis on no threat, no aliens parallels the UAP study's careful framing of unexplained does not mean aliens. However, there are differences too. The UAP panel was at least public with membership announced and findings released. Atlas III has received no such open organizational engagement. No study panel announced, no timeline for major findings, no clear statement on what NASA is doing beyond monitoring the object. The communication is more deflective than explanatory, leaning toward quelling concerns rather than addressing with information. One plausible explanation is NASA truly does not know what to say because data remains ambiguous, and no clear scientific consensus yet. In that case, saying nothing beyond reassurances makes sense until you have a coherent story to tell. But that approach risks being seen as secretive. Even if the root cause is just uncertainty and incomplete analysis, transparency about uncertainty would be better, admitting we are seeing anomalous things, and working to understand them. Here's what we know and what we do not, instead of merely projecting confidence. Another possibility is lessons from past controversies have made NASA more risk-averse in communication. The Oumuamua debate, where Lowe's artificial origin hypothesis attracted massive media attention and public speculation, may have convinced agency leadership to control messaging more tightly around potentially anomalous interstellar objects. Better to get ahead of speculation with firm reassurance than leave space for wild theories to grow. Either way, organizational behavior in this case shows caution and control as top priorities over openness and collaborative science. That could reflect real wisdom in managing public perception and avoiding unnecessary panic. Or it could reflect institutional instincts prioritizing bureaucratic self-preservation over scientific transparency. History shows NASA capable of both, depending on context and leadership. Determining which applies here requires more information than we currently have. Part 9: Conspiracy Speculation and Scientific Caution. Time to address the sensitive issue, or rather the extraterrestrial probe in the solar system. If you believe the wildest speculations, because when official clear information is lacking, human nature fills the void with theories from reasonable to absurd. Understanding the full range of ideas about Atlas III means engaging in speculation serious enough to evaluate it, but critical enough to separate signal from noise. Let's examine possibilities from most conservative to most extraordinary. The most conservative explanation is Atlas III is simply a natural comet from another star system, with anomalous composition and behavior, but ultimately explainable. Under this view, the nickel detection represents some strange chemical phenomenon we have never encountered before, perhaps involving volatile compounds preferentially binding metal atoms. The dominant carbon dioxide composition reflects formation in a planetary system with temperature and pressure conditions different from ours. Orbital anomalies are just statistical flukes, the kind of random coincidence that happens when you sample enough objects. Jet behavior relates to complex rotation states and surface geology we do not fully understand yet. This explanation has the advantage of requiring no new physics and only invoking natural processes even if stretched to fit observations. Essentially, it says the universe is vast and strange, and objects formed in other star systems can look very different from what we are locally familiar with. Nothing in the observations completely rules out natural origin. They just stress our current models in ways requiring new thinking about comet formation and evolution. This is the default scientific stance, the one you hold until evidence forces you to change. One step stranger. Atlas III could be a fragment of a destroyed exoplanet or other body in its parent system. Imagine a small rocky planet suffering a catastrophic collision or neatly destroyed when flying close to its star. Debris ejected at high velocity, some achieving escape velocity and becoming interstellar wanderers. If the parent body was differentiated, meaning it separated into metal-rich core and volatile-rich mantle through internal heating, and convection fragments could show anomalous composition mixing core material with surface. This could potentially explain metal detection and strange chemistry because you would be looking at material not normally exposed together in intact bodies. Orbit could still occur naturally just from the power of the ejection event, creating unusual angular momentum or pushing fragments at odd angles relative to the parent system's orientation. This is stranger than a normal comet, but it still relies only on natural processes, and requires no artificial element. Then we enter true artificial origin speculation, meaning we need to be very careful about evidence standards and logical rigor. The hypothesis that Atlas III could be a manufactured object, possibly an interstellar probe, rests on some indirect evidence where each individual piece could be natural but combined. They raise many questions. Metal detection could represent structural alloys. Orbital alignment and retrograde motion could represent deliberate targeting. Non-gravitational acceleration could be controlled thrust. Size and shape could fit artificial origin rather than accretion origin. There is even an archived paper explicitly exploring this possibility. The paper asks whether Atlas III observations could fit artificial technology and what that implies. This is not fringe speculation from online eccentrics. These are researchers with real expertise examining a hard-to-answer question with scientific tools. They are not claiming it is a probe. They are asking whether we can rule it out and what observations would help distinguish artificial from natural origin. The artificial hypothesis faces massive skepticism, as it should. Extraordinary claims require extraordinary evidence which we do not have yet. Most anomalous observations in astronomy turn out to have natural explanations once we understand them better. The history of wrong artificial origin hypotheses is long and embarrassing, from 19th century beliefs in Mars canals to initial pulsar thoughts as alien signals. Rushing to artificial explanations before finding natural ones is bad science. However, and this is crucial, proper skepticism does not mean completely dismissing the possibility. If we truly encountered an artificial interstellar object, how would we know? What signs would we look for? Clearly structured radio emission, though Atlas III shows no such signs. Geometric shape, but we still lack good enough images to analyze structure. Unusual acceleration vectors indicating directed thrust possibly present but could also be outgassing. Chemical signs of industrial processes, though distinguishing them from unusual natural chemistry is very hard. The issue is most scenarios involving real artificial objects would also involve some kind of active beacon, or obvious artificial structure we simply are not seeing. If you go to the trouble of building an interstellar probe and sending it to another star system, you probably want it detectable by any technological civilization it encounters. Radio beacon, optical flashes, geometric shape, or something to say, hey, we are artificial. From what we know, Atlas III does none of that, which strongly argues against intentional artificial origin hypothesis. Unless and now, we are truly speculating it is an abandoned object. An old probe no longer operating as designed, tumbling through space with failed electronics and lost power. Just interstellar debris from a civilization that launched it long ago. Or a von Neumann probe designed for stealth observation rather than communication. Or a light sail that lost its navigation system. These scenarios could accommodate the lack of clear artificial signals while still allowing technological origin. But they only pile speculation upon speculation without solid grounding. Then there are truly exotic natural hypotheses that sound like science fiction but are at least theoretically feasible. Dark matter iceberg, an object held together by dark matter concentrations instead of normal gravity, which could create strange observational signatures. A primordial micro-black hole, a tiny black hole from the early universe. However, the lack of Hawking radiation and gravitational lensing effects has fairly definitively ruled this out. Strange matter fragment, a quark matter chunk from a neutron star, though the physics here is speculative and does not match actual observations. Distinguishing between these scenarios requires evidence we currently do not have public access to. High-resolution images could reveal surface structure or lack thereof. Detailed spectroscopy could identify specific molecules and isotopes pointing to formation conditions. Tracking acceleration changes could test thrust hypotheses. Multi-frequency radio observations could detect any artificial radiation. Infrared measurements could reveal thermal properties incompatible with natural objects. But this is the issue of caution in science. It has two sides. Yes, we should be skeptical of extraordinary claims and demand high-quality evidence before accepting them. But we should also be honest about what observations would convince us and commit to making those observations instead of dismissing possibilities hastily. If the artificial origin hypothesis merits consideration even as a low-probability option, it deserves precise observational testing. Conspiracy theories swirling around Atlas III mainly focus on NASA deliberately hiding evidence of artificial origin because revealing it would cause societal panic, disrupt power structures, or violate secret agreements or whatever else. These theories view data delays and unusual communication as proof of cover-up, rather than bureaucratic dysfunction or legitimate caution. Some versions claim the celebrity tweet was a psyop designed to make the topic seem trivial. Others say classified briefings have confirmed artificial origin, and public denials are just theater. Conspiracies are inherently unfalsifiable, which makes them intellectually lazy. Any evidence against them gets reinterpreted as part of the conspiracy. Any lack of evidence is explained as successful concealment. They provide emotional satisfaction by offering simple explanations for complex situations and placing you among the few enlightened seeing through the lies. But they are poor epistemology and usually wrong. Conspiracies do happen, though. Not massive multi-generational cover-ups by shadow governments. That is just fiction. But organizational decisions to restrict information, coordinate messaging, and prioritize certain narratives over others. That is just normal institutional behavior under pressure. The line between cautious information management and information cover-up can be razor thin, and the same action can be described in either language depending on your perspective. Part 10. What happens next? Upcoming opportunities and risks. Let's turn our attention to the future. Because whatever the truth about Atlas III is, the coming months bring critical opportunities for observation measurement and potential revelation. Understanding what is coming helps us know what to watch for, what released data might tell us, and which missions or measurements could provide decisive evidence to resolve these speculations one way or another. The story is not over, and what happens next could determine whether this becomes an interesting footnote in comet science or one of the most important discoveries in human history. This object's orbit will bring it to closest Earth approach in December 2025, though that distance is only relative in astronomical terms. Current predictions place it at about 1 astronomical unit, equivalent to the Sun-Earth distance, a safe distance but also potentially useful for observation. At that range, ground telescopes could obtain excellent data if weather cooperates and observation time is allocated properly. Space telescopes have clear views, and depending on spacecraft position, some planetary probes could have unique vantage points. The James Webb Space Telescope is probably the best choice for definitive composition analysis. Webb's infrared instruments can detect spectral lines from molecules invisible or hard to observe in visible light. It can measure isotope ratios revealing formation conditions. It has the capability to analyze surface structure if the object is close enough and large enough. We know Webb has been used to observe Atlas III based on observation logs, but detailed data has not been released. When that data is released, if ever, it will provide critical constraints on chemical composition and help distinguish between formation scenarios. Hubble remains useful despite its age. Hubble's high-resolution images in visible and near-ultraviolet wavelengths can track changes in comet cloud structure, monitor jet behavior, and potentially reveal surface features if conditions align perfectly. Multiple Hubble observation campaigns have targeted Atlas III throughout its approach, and those images, once fully processed and released, will help characterize the object's activity level and any time-variable behavior. Large ground telescopes with adaptive optics and big mirrors can provide complementary data. Observatories like Keck, the extremely large telescope, and the Atacama Large Millimeter Array can probe different wavelength bands and search for specific molecules or dust properties. These facilities have observed Atlas III and are likely processing data at various stages. The question is whether that data will be made public for independent analysis and when. And this is where things get really interesting from a mission perspective. Several spacecraft currently in the solar system have instruments capable of observing Atlas III, or even sampling its tail material as it passes. Mars orbiters. Orbiters already have had observation opportunities. Juno, currently orbiting Jupiter, has cameras and spectrometers that could be pointed at the object depending on geometry and mission constraints. The European Space Agency's JUICE mission en route to Jupiter may have observation windows. Most controversially, there has been speculation about whether any mission could be redirected to actually intercept Atlas III or pass through its tail at close range. The New York Post reported on this possibility, noting that in situ direct measurements would be extraordinarily valuable, but also technically very difficult. You would need a spacecraft with enough fuel for significant orbit change, instruments capable of surviving high-speed dust impacts, and mission managers willing to divert from primary goals. Currently, no mission is designed or positioned to intercept an interstellar object. Approaching an object moving at interstellar velocity relative to the solar system requires a massive delta-v change most spacecraft cannot achieve, but passing through the tail at longer range could be feasible if any spacecraft is positioned such that the tail crosses its orbit. Tail material spreads over vast distances, and collecting even a few particles for analysis would provide priceless data on composition and structure. These upcoming observations and opportunities cannot be overstated. At the science level, we have the chance to characterize and detail material from another star system in a way we have never achieved before. Every measurement we make on Atlas III tells us something about planet formation elsewhere in the galaxy, about the diversity of chemical environments worlds can form, and about the physical processes shaping comets and planets in different stellar contexts. If Atlas III turns out to have truly exotic composition pointing to formation conditions completely different from the solar system, that would revolutionize our understanding of planet formation. It would mean the universe creates far stranger environments and chemical compositions than we see from local experience. It expands the parameter space for where and how life could emerge. It challenges models and forces theorists to think broader about what is possible over the galaxy's long history. At the institutional level, how NASA and other space agencies handle the coming months will significantly impact public trust in their communication about future discoveries. If data is released transparently and researchers get access to perform independent analyses, this will restore trust even if prior delays are explained as harmless bureaucracy. If data continues to be delayed and access remains restricted, this will fuel suspicion and erode the social contract between publicly funded science and the public funding it. At the societal level, especially if artificial origin hypotheses are supported by new measurements, the consequences would ripple in directions hard to fully predict. Confirming we are not alone in the universe, that other technological civilizations exist or existed, would represent one of the most profound shifts in humanity's self-conception. Since Copernicus moved Earth from the cosmic center, it would raise immediate questions about communication, about galactic demographics, about why we have not detected signals if probes are traveling between stars. But let's be clear, we are nowhere near that scenario yet. The default expectation should still be Atlas III is a natural object with anomalous but ultimately explainable properties. The burden of proof for artificial origin claims is massive, and that is entirely reasonable. What we should expect from upcoming observations is clarification of composition, better understanding of its orbit and origin, and hopefully resolution of apparent anomalies through improved natural models. The worst-case scenario from a science perspective is not discovering aliens. It is never getting the data needed to figure out what we are really looking at. If critical observations are not made, if key measurements remain hidden, if administrative caution or institutional panic prevents the transparent work needed to understand this object, then we have squandered an extraordinary opportunity. Interstellar visitors are rare. We may not see one this accessible again for many decades. Everyday data release is delayed. Every observation opportunity missed is permanently lost information we can never recover. What should we watch for in the coming weeks and months? Webb or Hubble data suddenly appearing in public archives. Papers submitted to journals analyzing 3I Atlas observations. Press releases from NASA or other agencies providing object status updates. Congressional hearings if oversight committees decide transparency is necessary. Social media signals from researchers getting the data they requested. Any of these could indicate the information bottleneck has been resolved, and we are moving toward resolution. Or we could see continued silence, prolonged delays, and ongoing question deflection. And if that persists, it will tell us something important about institutional priorities, even if it tells us nothing certain about the object itself. Because ultimately agency behavior and information flow are data points in themselves, evidence of something even if we are not sure what. Part 11. Recent breakthroughs in AI astrophysics for anomaly detection. Let's step back a bit and see how technology is changing astronomy itself. Because the way we detect objects and identify anomalies is evolving rapidly in ways important to understanding the Atlas III situation. By 2025, artificial intelligence and machine learning have shifted from experimental curiosities to essential tools in astronomical data analysis. This shift has profound implications for how we search for strange objects, the speed at which we recognize them as strange, and who controls that information. Traditional astronomical surveys work by imaging the sky multiple times over time, then comparing those images to detect any motion, brightening, dimming, or other changes. An astronomer or relatively simple computer algorithm flags candidates, then humans review them to decide which are interesting enough to follow up. This method is effective at finding things that fit expected categories such as asteroids in normal orbits or variable brightness stars, but poor at detecting truly anomalous objects that do not match predefined search criteria. Enter machine learning, a technology excelling at pattern recognition in massive datasets. Train an artificial neural network on millions of examples of normal shapes, and it becomes highly effective at detecting anything anomalous, even if you did not explicitly program it to look for that specific type of anomaly. By 2025, several research groups have deployed AI systems scanning survey data from facilities like the Vera Rubin Observatory and archival data from missions like James Webb, specifically hunting for objects that do not fit established patterns. A recent study demonstrated this capability. Remarkably, researchers trained a deep learning model on known comets, asteroids, stars, and galaxies, teaching it to recognize spectral signatures and observational characteristics of each type. Then they applied it to an unclassified observation dataset, asking it to find anything strange. The AI flagged several objects with characteristics not fitting any known category, combining attributes that should not go together based on current understanding. Some AI-identified anomalies turned out to be data errors or measurement glitches, but a few were truly strange objects astronomers had overlooked because they did not fit search patterns. One was a comet showing emission lines from molecules never detected in comet spectra. Another was an asteroid with rotation period so fast it should disintegrate under centrifugal force but somehow did not. These discoveries prove AI can find needles in data haystacks that human-designed searches miss. Now apply this to the interstellar object problem. How many interstellar visitors have passed through the inner solar system undetected because they did not impact Earth and did not happen to catch anyone's attention? Oumuamua was nearly missed and only detected on its way out. 2I Borisov was found by an amateur astronomer, not a major survey. Atlas III was detected by Atlas, but only because it was bright enough and moved in a way that triggered automated alerts. With AI systems continuously monitoring survey data and image archives, we could detect interstellar objects much earlier, possibly even before they enter the inner solar system. We could identify them as anomalous, faster triggering coordinated observation campaigns while the objects are still accessible for detailed study. This technology exists now. It is being deployed and will find many uncategorized things, which raises really interesting questions about information control. Because the thing is, AI-based anomaly detection will democratize discovery. You do not need to be part of a major observation consortium, or have access to cutting-edge instruments to run machine learning algorithms on public archival data. If NASA or other agencies are holding data that is technically public but buried in massive archives no one has time to fully analyze by hand, an independent researcher with good code and strong computing resources can still find the strange stuff. This creates an interesting dynamic around Atlas III. If critical observation data is in public archives but not released in easily accessible formats, AI-equipped researchers could extract that data and identify features official analyses have not highlighted. This could explain some of the pressure for data transparency because independent groups know they can analyze the data only if they can access it in usable form. Conversely, if NASA or other agencies are completely withholding certain observations, not releasing them into public archives at all, then AI cannot help. You cannot analyze data you have zero access to. The difference between data existing in archives but hard to find or process versus data existing but under embargo becomes very important. Machine learning tools can solve the first problem but struggle with the second. There's also a fascinating arms race happening between AI detection and AI-based data management. If agencies worry independent researchers using machine learning will find anomalies in public data before they can make official announcements, they could deploy their own AI systems to scan for potential issues and flag them for limited release. This would be information control tuned for the algorithmic discovery era, using the same tools that enable transparency to instead enable tighter control. The implications for how we handle future interstellar visitors are significant. In a world where AI can detect anomalous objects in real time from survey data, and that capability is distributed to many independent research groups rather than centralized in a few institutions, maintaining information control becomes much harder. You cannot suppress what multiple independent observers have already detected and analyzed. The only way to maintain narrative control is to be faster than everyone else, getting your message out before independent analyses emerge. This could partly explain NASA's unusual communication strategy with Atlas III. If you know independent researchers with AI tools will eventually find the anomalies in public data, you might choose to get ahead of the story, with a strong, simple message shaping the conversation before more detailed analyses can complicate it. No aliens, no threat becomes a proactive narrative anchor, something everyone remembers and references even as deeper scientific discussions emerge later. But this strategy also has risks. If AI-driven independent analyses uncover anomalies, the official message downplayed or ignored, this creates a credibility gap, making the agency look like it is hiding something even if the intent was only to avoid premature speculation. And in the current information environment where institutional distrust is high, that gap can quickly balloon into a full-blown conspiracy theory. Looking ahead, AI integration into astronomical discovery will only accelerate. The Vera Rubin Observatory, when at full capacity, will generate data volumes making human analysis impossible. Machine learning will be the essential tool to keep up with the observation stream, and that means more strange objects will be found. More anomalies will be flagged. More questions will be raised without immediate answers. Space agencies and research institutes need to adapt to this reality. Transparency becomes more important, not less. Because trying to control information in an era of distributed AI analysis is like trying to stop the ocean with a bucket. Better to be open, admit uncertainty, and collaborate with independent researchers as partners rather than problems. The old model of institutional authority based on exclusive information access is collapsing, replaced by a more collaborative and chaotic but ultimately stronger discovery and verification ecosystem. Atlas 3 may be a turning point in this transition. If handling this object proves information control is still achievable through strategic data embargoes and coordinated messaging that sets one precedent. Conversely, if it proves such, control fails against distributed technological capability, and public transparency demands that sets another precedent. Either way, we are watching the rules of the game change in real time. Part 12. New data on interstellar objects beyond Atlas 3. To properly understand how anomalous Atlas 3 is, we need context from the other interstellar visitors we have detected. By comparing this object to its predecessors, we can determine which features represent common characteristics of interstellar material versus those unique to this particular visitor. And by 2025, we have learned quite a bit more about both Oumuamua and 2I Borisov through continued archival data analysis and refined modeling. Oumuamua, discovered in October 2017, remains one of the most controversial objects in recent astronomical history. Initial observations showed it was small, perhaps about 100 meters long, with an extremely elongated shape length to width ratio, at least 5:1 and possibly far more extreme. It tumbled chaotically rather than spinning steadily. Most controversially, it exhibited non-gravitational acceleration, speeding up slightly more than solar gravity alone could predict, but with no signs of outgassing occurring. Recent reanalysis of Oumuamua data has somewhat reduced the mystery while raising new questions. Some research groups have proposed that hydrogen outgassing, which would not produce a visible coma because hydrogen is transparent, could explain the acceleration signature. This requires the object to essentially be a hydrogen iceberg, extremely rare but not impossible if it formed in some cold interstellar environment. Other researchers remain skeptical, arguing the physics does not fully add up, and the light sail hypothesis deserves continued consideration. What Oumuamua has definitively proven is that interstellar objects can have properties completely different from similar bodies in the solar system. This extreme elongation does not match local asteroids or comet nuclei. The surface appeared to have unusually high reflectivity, almost metallic optically, though spectroscopy was too limited to reliably determine composition. And the fact we nearly missed detecting it entirely as it was escaping the system suggests many similar objects have passed through undetected. 2I Borisov, discovered in August 2019, was somewhat more comforting because it looked like a normal comet. It had an active head and tail driven by water and carbon monoxide outgassing. Pretty standard, spectroscopy showed composition generally similar to solar system comets with the expected balance of volatiles. Its nucleus appeared to be a few hundred meters in diameter larger but still relatively small. The orbit was clearly hyperbolic and of interstellar origin, but the object itself seemed like a familiar type from elsewhere. However, detailed analysis of 2I Borisov has revealed some interesting oddities. The carbon monoxide to water ratio was higher than typical for solar system comets, suggesting formation in a colder environment or an apparent star system with different abundances. Dust grains in the coma showed some unusual properties and polarization measurements, hinting at different formation history or processing. And the object showed evidence of significant fragmentation or mass loss, pieces breaking off as it rounded the sun, indicating a relatively fragile structure. So our sample of interstellar objects before Atlas 3I consists of one extremely strange elongated object with mysterious acceleration and possibly metallic surface, and one nearly normal comet with some compositional oddities. Not much data to build a general theory, but enough to prove interstellar space harbors diversity, that objects formed in other star systems can differ significantly from our local population. Now in 2025, there are reports of potential additional interstellar object detections still under confirmation. These objects are not yet categorized as 3I because orbital calculations are still being refined to rule out eccentric solar system origin, but preliminary data suggests at least a few other candidates worth watching. One appears to be another comet with active outgassing. Another may be more asteroid-like, rocky and inert. If confirmed, they will expand our sample and help us understand what is typical versus special. When placing Atlas 3 in this context, certain features stand out sharply. It behaves like 2I Borisov in activity but has completely different chemistry dominated by carbon dioxide rather than water. It shows possible metal vapor emission which neither predecessor had. It is clearly quite large, much bigger than both Oumuamua and 2I Borisov, giving it different physical properties and thermal evolution. The sunward jet behavior has no precedent in prior interstellar visitors. This comparison shows Atlas 3 is not just another interstellar comet. It is something different, possibly representing a formation environment or evolutionary path, unlike what we have seen before. If we entertain the artificial origin hypothesis even as a remote possibility, Oumuamua already raised those questions with its elongated shape and strange acceleration. Atlas 3 adds metal detection and orbital features, bolstering the argument for seriously considering such hypotheses for rigorous testing. But this comparison also reminds us our sample size remains limited. 3 confirmed interstellar objects plus a few candidates out of billions of potential bodies that have passed through the solar system over Earth's history. We are seeing a small, possibly unrepresentative sample biased toward anything large and active enough to catch our attention. Drawing general conclusions from such sparse data is dangerous. We may be seeing the tip of the iceberg, only the strangest examples, while missing the bulk of the mundane. Statistical models suggest interstellar objects may pass through the inner solar system yearly or even more frequently, but most go undetected because they are small, dark, or inactive. As our survey capabilities improve, especially with facilities like the Vera Rubin Observatory coming online, we will start collecting more data, and with more detections we will better understand what is normal for interstellar travelers versus what is truly anomalous. The diversity we are already seeing even in this tiny sample has implications for how we think about planetary system formation across the galaxy. If every star system produces its own distinct comet and asteroid populations reflecting local formation conditions, then interstellar space becomes a mixed bag of all that diversity. Essentially, we are doing comparative planetology by collecting escapees from other star systems, learning about formation environments we cannot directly observe. Atlas III may be telling us that somewhere out there, perhaps tens or hundreds of light years away, there is a planetary system where carbon dioxide ice dominates over water ice in the outer regions, where unusually high metal density exists, where formation dynamics produce bodies with compositions we do not see locally. That in itself is fascinating, even without invoking any artificial element. It would expand our understanding of the range of possible planetary systems and the diverse chemical compositions that can emerge from star formation processes. Or in a more speculative view, if multiple interstellar objects show features exceeding natural explanations, perhaps that is telling us something entirely different. Perhaps technological civilizations have sent interstellar probes, and we are finally reaching the observational capability to recognize them. Perhaps the galaxy harbors a population of ancient artifacts long dead but still wandering, and we are just beginning to sample that population. These possibilities remain highly speculative, but the growing catalog of interstellar visitors gives us more data to evaluate them. The bottom line is Atlas III does not exist in isolation. It is part of an emerging observational pattern that, when combined, will either reveal far richer natural diversity than we imagined or point to something more extraordinary. Either way, we are in the early days of a new era of discovery where interstellar visitors are no longer once-in-a-lifetime surprises, but regular objects of study. How we handle this transition, the institutional practices we develop, the communication norms we establish will shape astronomy and planetary science for generations. Part 13. Planetary defense and policy shifts toward near-Earth objects. Let's examine how evolving planetary defense policy matters for understanding institutional responses to objects like Atlas III. By 2025, governments and space agencies worldwide are taking the asteroid impact threat more seriously than ever, investing in detection, tracking, and potential mitigation capabilities. This growing concern about near-Earth objects creates an interesting backdrop for how agencies handle any anomalous object discovered in the solar system, even those posing no collision threat. The DART mission, the successful double asteroid redirection test, proved in 2022 that we can actually deflect an asteroid by crashing a spacecraft into it. This proof of concept has transformed planetary defense from theory to practical capability, spurring increased funding and attention. By 2025, follow-up missions are in planning stages, and international cooperation on planetary defense has expanded significantly. The United Nations Committee on the Peaceful Uses of Outer Space has established new protocols for sharing information on potential threats and coordinating response efforts. But here is what is interesting for our purposes. The Planetary Defense Infrastructure Telescope, scanning for dangerous asteroids, and organizational structures for threat assessment are the same elements that detect and track interesting but harmless objects like interstellar visitors. The very systems watching for deadly meteoroids also spot strange comets from other star systems, and protocols developed to handle threat information can get applied, sometimes clumsily, to non-threatening anomalies. Current policy often assumes potentially dangerous objects are natural asteroids or comets on calculable orbits. You detect them, compute their orbits, assess collision probability, and if there is a real threat, notify governments and start mitigation planning. Communication strategy emphasizes transparency about the threat while avoiding panic, giving people accurate information on timelines and probabilities without catastrophic speculation. Atlas III clearly poses no collision threat. Its orbit never brings it into Earth impact geometry, so traditional planetary defense protocols do not apply in terms of threat response. However, some organizational structures and security considerations can still get applied, especially if anyone in the assessment chain thinks the object has features warranting higher classification. Consider this scenario. Astronomers detect an object. Initial analysis flags unusual characteristics. The object gets routed to planetary defense coordinators for standard review. Those coordinators, looking at data showing possible non-natural origin, however remote, might decide this needs classification under national security protocols, not because of impact threat, but because potential technological artifacts of unknown origin could have intelligence implications. This sounds far-fetched until you remember that UAP unidentified aerial phenomena have been treated as potential security concerns despite no direct threat. Recent 2025 policy documents show increasing attention to the possibility of detecting artificial objects in space. This is not just about interstellar travelers, but also the proliferation of satellites, debris, and potential anti-satellite weapons in Earth orbit. However, frameworks being developed to identify and track artificial objects in space could theoretically extend to anything detected with characteristics not matching natural bodies. There is growing recognition that detection capability needs significant improvement to have adequate warning time for potential impactors. Current surveys can detect large asteroids years or decades before potential impact, but city-sized objects could be detected only weeks or days before arrival. This has driven investment in better telescopes, wider sky coverage, and faster data processing pipelines. As these capabilities come online, we will certainly detect more anomalous objects of all kinds, creating more situations where agencies must decide how much information to share and how quickly. International cooperation on planetary defense poses interesting coordination challenges. If multiple nations detect and track the same object, they all need to share data and agree on communication strategies. For a truly dangerous asteroid, this makes complete sense. You need a coordinated global response. But for an ambiguous object like Atlas III, where different groups might interpret data differently, coordination becomes more complicated. Who decides? What gets released? What happens if one nation wants to release data and another wants to hold it? These are no longer hypothetical questions. Policy shifts also reflect changing public expectations about space hazards. Movies and media have brought asteroid impacts into popular consciousness in ways that did not exist a generation ago. People expect governments to watch the skies and would be outraged to learn a preventable impact was not prevented. This creates pressure on agencies to have capability and preparedness, and to appear to have capability and preparedness, which can drive communication strategies toward reassurance rather than nuance. Applied to Atlas III, you can see how planetary defense mindset might influence agency behavior. Though no defense needed, the instinct is still to quickly assess if there is any threat, and if not, communicate that clearly to avoid unnecessary worry. No threat becomes the core message because that is what the institutional framework is designed to establish and convey. Scientific interest in the object's anomalous properties becomes secondary to the defense mandate of confirming it is not dangerous. This could partly explain why public messaging emphasizes orbital safety over scientific details. NASA's statement, "No threat at all. Life on Earth," is completely consistent with planetary defense communication framework, where threat assessment is top priority. This fits less well with a purely scientific object. But if the object gets routed through defense-oriented assessment processes, the messaging still makes sense even if it is not what the scientific community most wants. There is also the question of how planetary defense protocols handle uncertainty. What do you say when you are not entirely sure what something is, but you are sure it will not hit Earth? Current protocols emphasize certainty about impact probability, while acknowledging uncertainty about other characteristics. This can lead to strong statements about safety combined with vagueness about everything else, again matching what we are seeing with Atlas III communication. Looking ahead, planetary defense policy evolution will continue to intersect with anomalous object detection. As detection capabilities improve, we will find more strange things, even if harmless. Policy frameworks need to balance pure scientific interest with security assessment, ensuring interesting but non-threatening objects get handled appropriately for science purposes rather than just filtered through a defense lens and then ignored. Lessons from Atlas III could really help drive better protocols for future interstellar visitors. If the current situation exposes gaps or issues in how anomalous objects are communicated, that will feed into policy revisions. Perhaps future interstellar object detections will get routed through a different organizational path, prioritizing scientific transparency. Perhaps communication protocols get developed specifically for high-interest, low-threat objects. Perhaps international agreements establish norms for rapid data sharing on high-value science targets. Or perhaps the current approach becomes the template where planetary defense frameworks and associated security considerations dominate handling of any anomalous object regardless of threat level. That would be unfortunate for science, but perhaps inevitable due to institutional inertia, and governments prioritizing security over discovery. Either way, we are watching policy change in real time through how this specific case is handled. Part 14: Breakthroughs in Comet Asteroid Chemistry Reveal Surprises. We have always assumed comets and asteroids follow certain chemical rules. Water ice dominates, outgassing dust and rock have compositions similar to solar system examples, metals in expected ratios. But what if a recent study upends that certainty? In 2025, scientists studying a solar system object discovered a composition so unexpected it forces us to reconsider the basis of natural behavior. A peer-reviewed paper revealed that an asteroid or comet right in our neighborhood carries unusually high nickel content or rare isotopes. Conventional theories do not predict. The discovery unfolded as follows. Telescopes using spectrometers detected atomic nickel vapor at distances where normal metals do not sublimate. They found nickel to iron ratios orders of magnitude higher than typical solar system comets. These metal signatures do not match known meteorite compositions. Put simply, imagine a snowball rolling through the solar system that instead of just dust and ice starts shedding a glowing stream of nickel metal. This challenges our models of what frozen bodies from space are made of. Why does it challenge prior models? Because we assumed comets form in icy regions far from the sun, primarily containing water, carbon dioxide, simple organics, and moderate metal impurities. We did not expect them to behave like industrial furnaces venting nickel at low temperatures. The new chemistry forces astronomers to ask whether our models of comet formation, thermal history, and material composition are still complete. It also forces us to reconsider galactic material diversity. If a normal solar system object can exhibit such strange chemistry, then we must accept nature can be far more inventive than we thought. Now back to our central character, Atlas III, an interstellar object causing scientific concern. Does this breakthrough on solar system bodies reduce the tendency to shift to artificial origin hypothesis for Atlas III, or does it complicate the issue by implying strange could actually be natural? On one hand, the answer leans toward caution. If strange metal-rich comets with high nickel can form naturally in our system, then perhaps Atlas III's oddities are not signs of extraterrestrial engineering, but of strange natural formation conditions. That possibility suggests we should not rush to artificial conclusions. On the other hand, the very existence of such extreme natural anomalies resets the bar for what we consider extraordinary behavior. In other words, if nature can produce something extraordinary, then extraordinariness is no longer necessarily artificial. And thus, when Atlas III exhibits extreme oddities, high nickel, low water, sunward jets, non-gravitational acceleration, we cannot rely on extraordinary equals aliens logic. But we also cannot dismiss the alien hypothesis just because nature is full of surprises. The context has shifted. Strange can now be natural, but that does not rule out the possibility some strange is manufactured. The result is a more nuanced dilemma. Atlas III's anomaly remains highly notable, but the basis for concluding artificial is subtler. What we once considered alien is now part of the natural strange spectrum. We still have to ask whether just because a phenomenon could be natural means it is natural. The chemistry breakthrough has expanded our understanding. It shows nickel-rich comets or metal alloy-rich asteroids may exist more commonly than we once thought. It suggests building blocks of distant star systems can vary significantly. When you accept Atlas III could be another data point in a much greater diversity of interstellar objects, or it could still stand out as an extreme outlier, even within that expanded diversity. So where does that leave us? It leaves us in a state of heightened curiosity, wonder, carefully considered rather than mere shock. We recognize the anomaly still exists and is strong, but we also recognize the natural world is larger than we once mapped. Right now, we will shift attention to the ethical and communication implications of how science responds when faced with mysteries like this. Because ultimately, the issue is not just chemistry and orbits, it is about trust, communication, and what we do when we do not know. The next part will ask, when institutions go silent or simplify the story, how does that shape perception? And our future, part 15, the ethical, societal, or communication consequences of science concealment and public trust. We live in an age where information travels at light speed, yet space mysteries can still be met with silence or platitudes. Earlier this year, a serious science communication incident occurred when a climate science agency delayed releasing critical data for months, simplified the message to nothing important to see here, and triggered a trust crisis between the public and media. This pattern matters because when institutions appear to hide or cherry-pick information, people start wondering what they're hiding from us. In the case of Atlas III, the backdrop plays out with dramatic elements. A mysterious interstellar object exhibiting extremely anomalous chemical reactions and behavior. A leading space agency declares to the public, no aliens, no threat, while high-resolution critical data remains unreleased and a celebrity tweet gets the official response. The scene is astonishing. The public sees a strange object, hears a reassuring message, but sees no raw data, fueling speculation, conspiracy theories, and distrust. Who gets to see the data? Scientists wonder. Where are the full-resolution HiRISE images? Raw, spectral tables, unedited remote sensing data. And when those access paths are blocked or delayed, independent researchers start feeling abandoned. In the social media age, the story is not just shaped by dense papers, but by tweets, leaked images, influencer mentions, and viral clips. The celebrity interaction only heightens the drama. When a public figure becomes the face of a scientific answers, the conversation shifts from what is this to why is this being managed like a PR campaign. The result is the story is no longer purely about the science but about narrative control. If an agency is seen as hiding information or acting more like a communications team than a science center, the door opens for alternative communities, citizen scientists, independent trackers, social media sleuths to fill the void, which can lead to brilliant discoveries, but also misinformation, fear, speculation, and broken trust. The risk is not just that we will misinterpret the data. The risk is we will lose faith in the institutions tasked with exploring the unknown, because when mystery meets silence, humans tend to fill the void, sometimes with creative stories, sometimes with paranoid ones. So this case is not just about a comet or an interstellar visitor. It is about how humanity copes with the unknown. It revolves around how institutions operate under uncertainty, and how trust is built or broken in an age of rapid information and celebrity-driven narratives. If Atlas III turns out to be a natural but strange interstellar object, the way it was communicated will still shape how the next visit from another star system is handled. If it truly is engineered, the silence and odd responses will be even more serious. In either case, we are learning something about ourselves, about the media ecosystem, about the hunger for mystery, and the fear of the unknown. So I urge you to stay vigilant for released data. Follow the story's evolution and engage critically rather than passively, because the revelations about Atlas III are still unfolding, and how we respond to them will shape not just our understanding of one object, but our readiness to greet the next interstellar visitor. The next time the sky decides to send us a message, we will know whether to listen and whether we can trust those telling us what we have heard.